we have discussed about the polynomial regression, right? So let us have a small recap. Okay, yesterday 6 p.m. batch was completed. That is the reason I was not able to take your class. That class only has lasted till 9:30. So that is the reason I have not able to take yesterday's that one. Okay, now anyways, let us have a small recap of this regression. Many of the students are having that doubt, and the previous classes some of the has missed or whatever it is. Just please focus once again on this part. You'll understand very clearly and real-time experience. Now this what is meant by regression? First understand what is meant by regression. Regression means predicting the output variable which is continuous. This comes under predictive modeling. This is the part of the predictive modeling. Okay, predictive modeling is nothing but machine learning. Machine learning comes under predictive modeling. Okay, whereas this predictive modeling means relation. Predictive relation means using the relation we are going to identify the future. Okay, first we are going to identify the relation, and based on the relation is also called as pattern. If you identify the pattern or relation, whatever it is, then based on that we are going to predict the future. Future means for unknown data. Predict on the unknown data. We are able to predict on the unknown data, right? So here predictive modeling means machine learning, where the machine learning identifies the relation between the variables. Whatever the variables you give, if you give this x and y means it will identify between x and y. If you give x1 and x2 means it will identify the relation between x1 and x2. Whatever the variable you have given, it will identify the relation. Whether that is XR, that is YR, that is independent or dependent, that machine don't know anything. You have given two things and it has to identify the relation between two things. Just it will identify the relation between two variables or multiple variables. Means just it is identifying the relation between the variables is called as modeling. Modeling meaning is relation between two variables. That relation is also called as identifying the patterns. Now within this predictive modeling, we are having one is supervised machine learning, and second one is unsupervised. Now what is supervised means where we are having some output label. Output variable will be there. Whenever the output variable also means you know the answer also before itself, then what you are going to then the calculations or the accuracy or measuring will be very easy. If you don't know output, then whatever we are saying we have to believe. For example, 1 plus 2 is equal to 5. If I say like this, you'll say that no sir, that wrong answer, it is 3. 1 plus 2 is equal to 3. Because you know the answer, you are saying that one. If you don't know this addition concept, then whatever I'm saying is right only, right? So in the supervised machine learning, what happens is it is going to have with respect to the output variable where already the answers are there. Just we are comparing our answers with the original answers. So here accuracy or error, calculation of error, this can be done. Whereas in unsupervised machine learning, this cannot be done also. You have to accept, right? Based on the pattern, whatever the pattern is there, we have to believe and we have to apply. That's it. Okay. Now, here in the supervised machine learning, whatever the output variable we are having, just we are going to divide whatever the data is there, the data we are going to divide into two parts. One is for training purpose and one is for testing purpose. Okay. In the train data, we are having the input and output. Output means original answer. And in the test data also, we are having input and output. Means once again, we are having the original answer. In the both the cases, we are having, this is training data. In the testing data, that is nothing but input is called as X train. This is called as Y train. This is called as X test. And this is called as Y test. But why it is called as train? Train means which is used for training purpose. Which data is used for training purpose? That is called as train data. This data is used for training purpose. It is not used for testing purpose. Means, for example, in the Python, when I am explaining, whatever the nodes in the Python, whatever the nodes is there, that is used for training purpose. Whatever the assignments are there, that is used for testing purpose. These questions are not used for training, or these questions, whatever the testing questions are not discussed in the class. Neither of. Both are independent to each other. There is no relation between both the things. Both are independent to each other. Right? Now here, first we are going to train on this. We are going to train on this. For example, let us assume I am training you on the Python concepts. I have explained you the input, that is code I have explained, and how you are going to generate the output also I have explained during the Python. Now I'm testing you on the new one, the new Python code, and I'm asking what would be the output in terms of. Now what you are going to tell, sir, if this is the Python code, this is the output, sir. You are going to say the output of this Python code is this one. Now this question, whatever the question I'm going to use is for testing purpose. Now whatever the output I have got, this output I'm comparing with my original answer. I'm already having the original answer with me. Just I'm comparing the original answer with this, right? Now this is called as testing. Now which is used for training. The machine will understand the data and we are testing the machine. This is called as testing, right? Now testing, okay, fine. It has tested, fine. But here the thing you have to understand is few things like one, ML algorithm. What is meant by ML algorithm? Two, what is meant by data? What is meant by different machine learning algorithms? What is meant by algorithm? What is meant by algorithm? What is meant by data? And what is meant by machine learning algorithms? Okay, algorithm is the way of learning, the way it learns. In the linear regression, it will learn in a different way. In a non-linear regression, it will learn in a different way. In a KNN regression, it will learn in a different way. The steps, the flowchart of learning, the way of learning is called as algorithm. There will be steps. In that steps, it will learn. Data means whatever the input you are giving. Input. ML algorithms means different ways of learning. Now here, let me explain with a simple example for your understanding purpose. Here there is a nodes. The nodes is ML. I have to explain the ML or DL or data science, whatever it is. Some subject. Okay, subject. Nodes is nothing but subject. I have to explain the subject. The subject is called as data. Subject is called as data. Now the way I explain, the way of my explanation is there, right? I will explain in a different way. Other person will explain in a different way. I will explain the different examples by explaining a different examples. For example, if you take this example, I am writing. Maybe other trainers may write, may not write. So the way of explanation is called as ML algorithm. Okay. Now, based on my way of explanation, you are understanding the subject. You are understanding the given data. And based on that, tomorrow in the interview, if they ask you any questions, you are able to tell the answers, which in the testing purpose. They are going to test you. Whatever you have learned in the class, they are going to test you. Now here the subject, the way of explanation is there. Now, whatever the concepts are there, subject in terms of, in the subject, core Python is there. Within the core Python, loops concepts is there, functions are there, pandas is there, data, inferential statistics is there, descriptive statistics is there, like probability is there. So many concepts are there. When I'm explaining the probability, many of the students has felt very happy and they have felt it is very easy. Whatever I have explained, they have felt very easy way. When I'm explaining the hypothesis testing, many of the students has confused with respect to the hypothesis testing. Now, data to data, your way of learning also different. All the data will not be the same, right? Though I am only explaining, the way of explanation is same, the trainer is same, everything is same. ML algorithm is nothing but trainer, SRK. ML algorithm 1 is SRK. ML algorithm 2 is some XYZ. The XYZ will explain in a different way. But whatever the way he explained, at the end, it is the same subject. Subject is same. But each trainer will explain in a different way. Now, whatever the subject is there, all the subjects like inferential statistics will not be the same as data cleaning, or data cleaning is not equal to for loops, or for loops is not equal to functions. Each concept is a different one. Now you are going to learn. Now in the real time also, the data will be different. So we can't fix the same pattern. Sir, you have explained the probability with very simple, means that concept is very simple. That is the reason we have understood very simple way. Whereas inferential statistics, null hypothesis and alternate hypothesis, the two opposite things we are learning simultaneously. Two things we are learning, the two opposite way we are learning. Automatically it will be in the confusion. That too, there is a confusion matrix which makes it still more confused with respect to. So, whereas inferential is not that much of easy when compared to descriptive statistics or with respect to the probability or with respect to a normal core Python. Similarly, in the real time also, all the data will not be the same type. Real time in the data will not be the same type. So same type of data will not get. So we'll have different types of data, different types of situation, different purposes, right? So in the data, for example, let us take some data, students. The data is students, whatever the students are there. The students, whatever the way I explain, these students are understanding clearly, other students may not understand clearly. For example, if you any one new student is joining in my class today, assume, and he sits in the class. Now, though I have explained for example, there will be some institutes or some things, and one of the institute has asked me like this, sir, my students require with respect to only the projects, sir. They already completed data science course. Now you have to explain only them the projects. They require only the projects. They have to keep in the resume. Only projects are required, it seems. They asked me like this. Now, if I start explaining one project, I will say data cleaning. They will say that, no, sir, this topic was not covered for us in the class. I will explain hypothesis testing. No, sir, this was not covered in the class. I will say ANOVA test, sir, this was not covered in the class. F test, sir, was not covered in the class. Evaluation, sir, not covered, sir. Then what you have covered, Ra? Then what you have covered? Sitting in the class and seeing the body covered. This same thing was happened. I am explaining for them. I am explaining the train accuracy versus test accuracy, and I am explaining overfitting and underfitting. Sir, my trainer has not explained this one, sir. He has told only to predict on the test data and to see the test accuracy. Model was completed. Now, for these people, how I can explain? Actually, the project has to be completed in 3 days. Generally, the project, whatever I am explaining, it will take 4.5 hours. Assume the complete end-to-end project I have to explain this. It is taking 3 days. Now, they don't know many of the concepts. Now, what happened? One project has taken 30 days because I have to explain so many things. What is overfitting? What is underfitting? What is cross-validation? K-fold cross-validation. He said that what happens? Now, for you guys, I don't need to explain because that already covered in the class. Example. I'm saying example. Okay. Here, the thing is that the students, whatever the students are there, they are also data science students only. They are not special students. They are also data science students only. Data science students with no knowledge. If they are having knowledge means they can do their own projects. Since they are not having the knowledge, they are asking, sir, can you give the project? Now, in this situation, what we have to do? So the students will be different. Similarly, that I don't want to stress on the students. I'm stressing on the data. My intention is with respect to data. Data will be different types. So based on the different types of data, different types of situation, we have to clean the data. We can't apply the same rules every time. According to that, we have to clean. Right? So data cleaning or data wrangling or with respect to whatever is there, it depends upon data to data. There is no fixed rule. Okay, for everything, this is the rule we have to follow. It's a random state number, fixed. Test size, fixed. And normal distribution to skewed to normal, fixed. Outliers to be removed, fixed. There is no like that pattern. If every pattern is fixed, if there are outliers are there, if there are outliers, remove. Yes, don't do anything. I can't write this code. If the data is skewed, convert the data. If the data is not skewed, don't convert the data. If and else, I can use if and else and I can create my own program, right? Everything will be completed by creating one my own program, right? I can create a user-defined function for that, right? By using the for loop for each variable, for I in each variable, automatically it will check for each of them. It will check the missing values. If the missing values are continuous, automatically apply this one. If the missing values are discrete, apply this one. I can write everything. Fixed code is there, means fixed program also will be there, right? Fixed program will be there or not? Yes or no? If the fixed pattern is there, first step, this one you have to do. After that, this one you have to do. If this is not miss, this one not miss, this one, either of you have to apply. And finally, you have to do this one, miss fixed program. Na? Then I can write my own fixed program by using for loop, right? By using for loops and within that if and else, right? But there is no fixed program. If everything is fixed, there is no data science demand. Then the demand starts with respect to AutoML into picture. Why AutoML has failed in the market? Because every data is a different one. It is not predicting in a proper way. Whereas manual, whatever the manual ML is making with respect to better results when compared to auto ML. When compared to auto ML, but artificial intelligence replication of this one. Artificial intelligence is entirely different one. Machine learning is entirely different one. Right? Now here, whatever the data I'm having, the data, first I have, see, I'm writing the steps, not fixed steps. You don't write anything, just understand first. First, we have to understand the business problem. Common, 100% we have to do this mandatory. Clearly, we have to understand for what purpose we are doing the project. Step 2, which is called as data understanding. This is also mandatory. Data understanding means understanding each variable, understanding the data set. Both of them is called as understanding. Inside your data, how many continuous variables are there? How many discrete variables are there? Separate the continuous variable, separate the discrete variable. And this is with respect to data set. Data set to data set, it will changes. And in the data set, how many rows are there? How many columns are there? Inside that columns, how many continuous variables are there? How many discrete variables are there? Everything changes data set to data set. If the data set column name is having with respect to something like says in bracket dollars, thousands of dollars, this cannot be used as the column name. It has to be replaced. We can't use this one as the column name. Whenever you are using this one as a column name, it is going to throw an error because variable name cannot consist of special characters like this. Right? So this cleaning has to be done. So that we have to observe. First, we have to observe. Once this is completed, now we have to move on to the third step, EDA. Okay, EDA. And we have to analyze the each and every variable. Analyze and understand each and every variable clearly in order to proceed for the data cleaning. In the data cleaning, you should not get the doubts. For that, first we have to check how many unique values are there. If it is a discrete variable, how many unique values are there? Which value is repeating more? Value counts or plot, bar plot, count plot. All this comes under into that. Okay. For example, you want to repeat. You want to replace discrete variable. Which one you want to replace? Which is repeated, most repeated one. That one you have to replace. If you want to drop means you'll drop. If you want to replace means most repeated one you are going to replace for discrete variables. For that, first we have to see which is repeated. That should be done in the EDA only. EDA is understanding each and every variable or understanding your data, understanding your raw data very clearly. Understanding the given data. Given data is called as raw data, not the clean data, raw data. Okay. So these three are mandatory. There is no fixed order. This is fixed order. You have to do in this way only. There is no changes. 100% you have to do in this way only. Up to this fixed code. After this, so this thing, whatever we have done, we are going to save in a Jupyter Notebook 1. Keep this one in a Jupyter Notebook 1. Okay, this entire things up to EDA, you keep it in a separate one. Okay, now you start the next step called as data pre-processing. Now come under step 3 called as data pre-processing. Okay, so if you want to write, you can write. Okay, this one you keep in the Jupyter Notebook 1 and save it and forget. This is the raw data. Anything details of raw data will be in this Jupyter Notebook. All the details of raw data will be in this. That is the original data. Details will be here. Whatever the observations you have done, write for each of them inferences. From this, whatever the inferences you have got, inferences or conclusions, whatever you have got, write everything. Whether you are going to write in the Jupyter Notebook, whether you are going to write in the PPT, that is your choice. But write whatever you have understand. Mention everything. Is that clear? This is compulsory steps and everyone has to follow the same order only. You can't change the order. You can't change the anything. 100% you have to do in the order. For continuous variable, continuous analysis, you have to apply separately. Discrete variable, discrete analysis, you have to apply separately. So that is the reason you are separating all the continuous variable into separate one list. Take one list. List of continuous variable. Apply the for loop for this one. Box plot, you apply for loop. Histogram, you apply the for loop. If you want a pair plot, directly apply the pair plot. Pair plot directly itself, it will give the histograms and scatter plots in directly itself. If you want to apply joint plots also, you can apply joint plots. Whatever the plots you want, apply for the continuous variable separately. First, separate the continuous variable into a list. Take the discrete variable into a separate list. Separate. Now, for this data, you apply the bar plots, pie plots, whatever it is there. Apply using the for loop. Right? And for each of them, whatever you have understand, from each plot, something you'll understand. Whatever you have understand, you write that point. This in the company, it will take 15 days. 50, I mean, in terms of weeks, if I want to say, 3 to 4 weeks it will take. Only EDA. Only this one will take 1 week and this will take 1 week. I'm saying approximately, not exactly. In some scenarios, it may take 2 weeks also. In some scenarios, it may take also 2 weeks. Remember, morning they are not going to, for example, morning if they give the project or data, by evening we are not going to submit the project report. We are not going to complete in single day. We have to do that one in the 4 months of time. Before to data, in this data collection or deployment, both are not included. Data collection is data engineer work, deployment is software engineer work. I'm saying exclusively data scientist work only. In this project time period, whatever I'm saying 4 months time period, in this 4 months, neither data collection is included, neither deployment was included. Your part is whatever the data you have got, analyze the data and create the pattern, identify the pattern and identify the relation and save that relation, whatever the relation is there, save that one and transfer that one. Your work is completed. Your work is to identify the pattern. Identifying the pattern is the main work of the data scientist, which improves the business. Identifying the pattern which doesn't improve the business, no need of identifying that patterns. If that pattern is there also, no use. If the pattern is not there also, there is no use. Which improves the business performance. That one. Right? Is that clear? Now, here, next one is data pre-processing. Now we are moving on to the data pre-processing. Now open the again a new Jupyter notebook. Jupyter notebook number 2. Go with the Jupyter notebook number 2. Now in this Jupyter notebook, again once again reload the data. Anyways, you have not done the cleaning, right? You have just observed the patterns only, observed the graphs only. You have not done the cleaning in that. So nothing was there in that. Now again you load the Jupyter notebook. Once again you load the data. Okay. Once again you start. Now in the data pre-processing, first one already EDA was completed. In the previous Jupyter notebook only EDA was completed. Now here you have to do the data cleaning. Do the data cleaning. Okay. Out of which missing value is compulsory. If you keep the missing values without replacing the missing values or without dropping the missing values, what happens is the machine learning algorithm, whenever you are fit the X train, Y train, if you give the data like this, it will throw an error. Miss, for example, if you share the nodes, what is meant by machine learning algorithm? It learns. Algorithm is the way of learning, but it has to learn the data. While learning, for example, if I share a book where the book is consisting of 4 pages and the 5th and 6th page is missing and 7th page is there, can you read properly? You can identify correctly of the 7th page, you'll understand, or you'll by heart that one. If it is mandatory, you have to, tomorrow exam is on the 7th page, but 5 and 6 are missing, then what you'll do? You'll by heart, finally. Blindly you will by heart and you will go to the examination hall and you will open the last page and you will write as this first. And after that, you will start the first page. First, whatever is in the brain, we'll write everything in the rough paper. Then we'll go to the first page and then if the question was given miss, we'll go to again to the rough book and we'll copy that one. Right? That is called as by hearting. For understanding people, nothing will be there like that. Right? So now, just here, with respect to this, whatever the missing values are there, the machine will by heart. If the missing values are not there, the machine will understand. So that is the reason 100% we have to do the missing values treatment. Mandatory. Treatment of missing values is mandatory. How we are going to treat is, options are yours. But treatment is mandatory. This is mandatory. Whereas, drop duplicates. You have to drop the duplicate values. Whatever the duplicates are there, you have to drop all the duplicate values. This is also mandatory. Otherwise, what happens? Otherwise, overfitting problem will be there. Same data, if you ask, same example, you are asking me one question. I have given you one answer, one explanation. You have asked the question, I have given one example. You have not understand that example. Again, I am explaining the same example. Again, you are saying like this only. Again, I have explained the same example. I am trying to I am forcing that example. I am not giving the new example. I am forcing the example. Then what happens? It leads to the overfitting. If I give different examples every time, if you not understand this, change the example. Now what happens? Subject clarity will be there. Getting the point? So now duplicates are there, means it is going to lead to the overfitting. The problem with that is overfitting problem. Now, this is also mandatory. Whereas next one is outliers. It is optional. Sir, why it is optional, sir? Why we should not clean? For example, in this class, I have kept an exam. I have kept an exam. Today, I have kept an exam. Suddenly, I have kept an exam. In the exam, I am asking the questions. Now, all the students has got with respect to 70 to 75 marks in between, but one student has got 100 out of 100. Why other students has got this one means because I asked out of the syllabus, like a KNN regressor or decision tree. I have asked now itself. Actually, I have not discussed to these people. In the class, I have never discussed, but in the exam, I have asked this particular student has already done the data science course, some other institute or with some other trainer, and he has rejoined in this. He are already familiar with that one, assume, in this situation. Now, can I consider this person as an outlier? And can I remove that one? Outlier, okay. But I can remove? No. I can replace with the maximum value of 75? No. In this case, that person also should be included and we have to analyze. Okay, some students will be there who will come from other batches and they will sit in this batch. And according to that, we'll have to analyze. Right? Unexpectedly, I have told, but it indicates to one person. But unexpectedly, I have told this example. Right? Now, this is with respect to example, where outliers are optional. It is not mandatory. Right? Whereas second one is data wrangling. Next, we have to move on to the data wrangling, where encoding is mandatory. If you don't do encoding, why it is mandatory? Because if you don't do this one, again, you are going to get the fit will not be work. It will throw an error. Fit will not work. Machine will not understand. Machine will understand only numerical data. Next, with respect to encoding is mandatory, whereas transformation, if you give the wrong answers, if you give a wrong data, wrong answer will get. But you can give. Transformation is okay. And that is not compulsory, optional. That is an optional. Compulsory things are, these two are compulsory. In the given data, these two along with this one, okay, these two and this one, compulsory you have to do. Remaining is optional, whatever you want, you can do. Now, what I am going to do, now don't write. From now, there is no pattern is there. Till now, there is pattern is available. From now, there is no pattern. Now, don't write because I only don't know what I am going to write. That is the reason. Okay. Once I write completely, then I will ask you to write, then you can write. Okay. Now, the thing is that first you have taken the data and you have understand. You have done the data cleaning. Data cleaning. After data cleaning, you have done the train test split. You are going to do the train test split. After that, you are going to apply the machine learning algorithm. And if the machine learning algorithm is good, miss, okay. If this machine learning algorithm is not good, miss, you are changing the ML algorithm. If this is also not good, miss, you'll change another algorithm. If this is also not good, miss, another algorithm. If this one also good and this one also good, this one also good, this one also good, miss, which is the best, that one we are going to select. If not good, miss, no question. If everything good, miss, then also question is there. That is which one has to be selected. So out of which one, which doing the better performance, that one we are going to select. Right? For example, in the interview, student 1, student 2, student 3, if 2 students are not performing, student 3 performing well, miss, automatically select. But 3 students are performing very well. In the interview room, 3 students are performing well. Then you have to select 1 student, miss. Best one. Similar way here also. Similar way. Now, here the student 1 and student 2 and student 3. Assume that first student has got 90 marks. Second student has got 95. Third student has got 95. Now, which student? Which student? Which one? Which person you are going to select? One. You have to select only one. Next priority is immediately salary. Who is going to ask the low salary? Both are same knowledge. Both of them are having equal thing. Both of them will complete my project. If I take them, both of them will complete. If this person is asking 4 lakhs and this person is asking 6 lakhs, why I have to pay 6 lakhs? In 4 lakhs only my work is getting completed. Money is not with respect to free, right? So obviously I will go with the low salary. Second option is low salary. First one is, what is the top priority? First priority is, first and top priority, top one priority is score. First top priority is score. For example, let us assume this person is having only 65 marks and he is demanding for 3 lakhs only. Marks are 65. 95 marks and your expected package is 5 lakhs. Now, which one? Obviously, now we'll go with the third one only, because though the package is more also, our work has to be completed. For example, this person I have taken and my work is not getting completed. What is the use of paying 3 lakhs also? That is also a loss only for me. With that person, I have to complete my project. This person is not having the capability of completing the project. This person is having the capability of completing the project. But he is demanding more. But still I have to pay. There is no other option for me. Only this person is capable, miss, obviously I have to pay for him. Initially, I will pay for him. Later, once the work is completed, I will remove him. That is secondary. My task is completed, miss, I will remove. Whenever the ration time comes, I will remove. To whomever I feel that I am paying more, I will remove them. Again, I will hire with respect to the people having of same knowledge who are demanding with less package. Same concept is running in the market as of now. Whoever they have feeling with respect to the knowledge and the salary, the same knowledge we can get with low package, miss, they are removing those people. Okay, at the demand time they have demanded. Now demand is completed, they are removing. Demand and supply. Right? Now, here the top priority, first priority is with respect to the score, second priority with respect to the salary. Now, similarly, in the algorithms also, first priority we have to give with the accuracy is the top priority. If the accuracies or everything are same, if the score is same, second priority, how we have given salary, here we have to give the second priority for time, which can be implemented in less time. That is second priority. Which is the same answer. Same answer you are getting. In 5 minutes you are getting, the same answer you are getting in 8 minutes. Which one you are going to select, miss? Which gives in the 5 minutes, obviously. So, similarly, here what we are going to do, miss, after doing the train test split, we are going to fit the data. So, let me write in this way. So, data cleaning. Once the data cleaning is completed, we are going to do the train test split. Train test split. From that, we are going to apply the machine learning algorithm on trained data. Trained data. And after that, we are going to do the evaluation. Evaluation with respect to certain amount of data, and we'll cross-validate if I change the data, how it is performing. Cross-validation. As the data changes, how the model is performing is called as cross-validation score. For the fixed data, for example, let us assume you are going to take in the future NASCOM exam. In the NASCOM exam, you told that I have got 75%, sir. 75%. Okay, fine. If that questions are given, you have got 75 marks. If the questions changes means your marks can be improved or decrease. Anything can be done, right? Either it can be increased to 85 or it can decrease to 65. Anything can happen. You may fail also if difficult questions are there. For that questions, you have got 75. If I change the questions, miss, so that is called as cross-validation. As number of questions, number of exams, if I change, that is cross-validation. So I'm going to do the, after evaluation, I'm going to do the cross-validation. If the cross-validation and evaluation both are nice, okay, then okay, I can conclude that this model is very good. Now, like this, I'm going to train the machine learning algorithm 1. Okay, first machine learning algorithm 1. I'll take machine learning algorithm 1. Same thing I will do. Already data cleaning is completed. Train test bed is completed. Up to here it is completed. Now I will change this data. I will change to the machine learning algorithm 2. Now again, I will not start with the data cleaning. That data I will transfer to the ML algorithm 2 and I will evaluate the model. Evaluation and cross-validation. Next, I will give the data to ML algorithm 3. Though my requirement was satisfied, for example, my client has asked me with 80% you have to predict. My requirement was satisfied with the ML algorithm 1 only. Maybe ML algorithm gives 85%. If more accuracy you are getting, is problem for you. All right. You may get, you may not get. Sir, like this, how many we have to try, sir? Whatever the time is set, till the time you do the best. Within the given time, do the best. For example, they have given for you time of 1 month. Your work was completed in 1 week. Remaining 3 weeks, instead of sitting silently, you do the betterization. If you do the betterization and if you get the more better results, what happens? In the future, you are going to get the promotion when compared to others. You can take light also, right? After 1 week, you can take the light and okay, my work is completed and I can enjoy. You can do in this way. You can do another way, betterization. 2 options you are having. If you do that one, first one, option number 1, that taking light and okay, completed, my work is completed, I will enjoy and I will open my YouTube and I will start watching some videos or I will complete some web series. If you can do this option means, when compared to others, others will fly away in front of us only with their salaries, right? So betterization, we are going to do the betterization, still more betterization. Always we'll try for the betterization. Okay. Sir, like this betterization means after 1 month also still we can do, but time will be completed, right? Within the given time, whatever you can do, you have to do the best. Within the given time, the best. So ML algorithm 3, you are trying and evaluating and CV. And ML algorithm 4, you are trying and you are going to evaluate and you are going to check the CV. Now, after doing all these things, now which models are best models, good models, not best, good. Only good. Identify the good models. Once this is completed, identify the good model. Good models. So identify the good models and along with that, best model. For best model, models, not models, model. Whereas good models are there. For example, what is meant by good model means, whichever the model is not having any kind of overfitting or underfitting problem, that is every model is called as a good model. Which is the best one means after comparison everything, which is the final one, that is the best model. That is the difference between good versus best. Is that clear? For example, here I am having overfitting problem. Don't sell it. This is not having neither overfitting nor underfitting and cross-validation score is equal to test accuracy. Everything is fine. Go with this. Good. Good only. Not best. Good only. This one also good. This one also good. Now, out of these 3 goods, one will be the best. identify that best. Once you identify that best model, save that model. With this, your work is completed. With this, your work is completed. Now, when this work was completed, in the future, now assume that this is the model. Model was designed. I have deleted. Okay. Now, I will write here. The best model is designed. Once the model was designed and you have shared to the deployment team or to the client, now in the future, they are going to send a new data and they will predict the output. Whatever the output they want, they will predict using the model. Means what they are doing, directly they are giving the data to this model. Before sharing to the model, they'll share this one to this one. Data cleaning they'll do. Means whenever you are working on the test data, on the new data, now new data, whatever the new data is there, the new data first it will be cleaned or transformed. For example, the data was designed based on the one of the variable was converted to log, or one of the variable was converted with respect to another variable. Here also the variable has to be converted. Here the encoding was done. Here also we have to do the encoding. Without encoding, how we can give the text data? That data has to be converted and then only we have to pass into the model. Because model was designed on the encoded data. Model was not designed on the text data. Model was designed on how many features? New data also should have number of features same. That to same order. The sequential order, whatever the column names order is there, that to the same order it should have. If the order changes also, answer will change. Right? Is here what the value was encoded means here also this new data has to be encoded. Cleaning and encoding has to be done. Then it is going to send to the machine learning. Now the machine is going to predict the answer. Now you are not going to check the train accuracy, test accuracy, already completed. Checking evaluation is completed. After evaluation, just you are predicting only. To be more simplified for you, now in the class, now you are the students. The students assume that it is my data. Now what I am going to do is data cleaning. Data cleaning means you are having whatever the doubts you are having, I am cleaning that one. Right? Your doubts and whatever the things are there, I'm explaining from the basic levels. And after that, I'm explaining the each algorithm. And after that, I'm evaluating whether you have understand that algorithm or not by keeping some exams. Okay, and I'm going to cross-validate by with respect to different mock interviews. So your mock interview is going to be day after tomorrow. Okay, your first mock interview is going to be day after tomorrow. Till whatever the things we complete tomorrow, till that syllabus. And to whom I'm going to select randomly. Okay, pure randomly I'm going to select lucky draw. Okay, np.random.choice. Right? Real only. Real mock interview. You have to sit in front of me and I have to ask you the questions and you have to answer me. Whatever the original interview is going to be, the as-is interview will be there on the day after tomorrow. Randomly, 2 students from this online and 2 students from offline. Right? Now, I'm going to do the cross-validation. Once I do the cross-validation, I'm making sure that my students are doing the best in the industry. Why I'm doing that one day after tomorrow mock interview? I can take the mock interview at the end, but why I'm doing in between? Because I want to check if I make sure that in between multiple mock interviews, now you'll start preparing. Generally, the student psychologists, one day before only we will prepare, right? Now, if I start now itself, now at least something you'll prepare. Based on the analysis, just I'm going to do that evaluation. Now cross-validation. Now whatever I have done, this is in the training. In the class, training is completed. Training completed and evaluation also completed by me. My own evaluation is completed. Model are ready. Model are ready means students are ready. Now this one, in the interview room, they are going to ask you new questions. They may ask same questions what I have asked in the class. They may ask new questions also. And you are going to predict the answer. That's it. Is that clear? So just we are applying the same logic here. Right? Is that clear? Anyone, any questions? So here the machine learning algorithms, multiple algorithms, we are going to share the same data. Train test split. After train test split, we are going to share the same data. Whatever the train data you have given, the same train data should be shared to all the algorithms. You should not change the data. Data should be fixed. Why it should be fixed? Because you are comparing the algorithms. When you are comparing one thing, remaining all the parameters should be constant. For example, let us take an example. 1 plus 2 plus 3 is equal to 6. 2 plus 2 plus 3 is equal to 7. 3 plus 2 plus 3 is equal to 8. Since all these remaining two parameters are constant, now as this value increases, how this value is increasing or decreasing, I can able to predict. Now assume that 1 plus 2 plus 3 is equal to 6. 2 plus 1 plus 3 is equal to 2 plus 2 plus 3 is equal to 7. Now 2 plus 1 plus 4 is equal to, or 2 plus 2 plus 4 is equal to 8. 2 plus 1 plus 5 is equal to 8. Something you are having like this values. Now how you can identify the relation? And for which values it is increasing or decreasing, how you can say? So when we want to compare the machine learning algorithms, the data should be fixed, right? With respect to the ML algorithms, whatever the ML algorithms are there, just we are going to give the same data. Train data should be the same. Then only we can compare the algorithms. If the train data changes, we can't compare. Comparison can be proper comparison. We have to do means remaining all the parameters should be the same. Here there is an example called as salary prediction. Okay, we are having a salary prediction where example only. Don't write the notes and don't ask me to share. I will share later. This is later class. Just an example only I've brought, right? So here we are having with respect to experience based on the test score and interview score. We have to predict the salary of a person. Now I have to identify the relation between experience, test score, interview score versus salary. What is the relation between them? Now what I'm going to do is, just first I'm going to do with respect to data cleaning. And in the data cleaning, I have observed two are missing values. Two columns are having missing values. Out of which, first one, experience. Experience is a continuous variable. Basically, experience is a continuous variable. But here, I'm going to replace either with mean or median. Instead of replacing that one, I'm replacing with 0. Here, I have to understand the context. What is the context? The experience he has not filled in the form. The experience value he has not filling the value means what is the meaning of that? He is not having the experience. If he has experience, he will fill now. Why he is not filling that experience column is because he is not having that experience value. He is not having experience. So then I'm going to fill that experience with 0 directly. I'm not going to take the average value. I'm not going to take the median value. I have to understand the context. What is the context? And text score, average score. Okay. And I'm taking X and Y and I'm splitting the data of this one and applying the linear regression over that. And I have got with respect to the evaluation 94 and 92%. Now I'm predicting on the new data, completely new data. Here there is no data with 499. Is there any 499? Experience 4 is there? 499. Is there any value of 499? No. On a new data, I'm going to check whether it is so I'm predicting for the 499 and I have got with respect to like this. Now because my model was designed on 3 columns, so I have to give the prediction also with respect to 3 values, and that too the 3 values should be in the double square bracket because the input data is a data frame. It is a 2-dimensional array, so we have to give as the input as a 2-dimensional array. We can't give as a 1-dimensional array. Right now, so here if I predict, I'm getting the 65,245. Now I'm going to save the model and I'm going to share to the deployment team, and I will say to the client that, sir, this is the best model which gives the 95%. Your requirement satisfies by this model. Completed. My task is completed. Now the deployment team is going to create a website. Inside this website, they are going to give the values. They are going to create a website like this where we are going to fill the values like 499. And if you click on the predict, you will get the same answer, whatever. Here you are getting this answer, but how? How you are getting this one, miss? What is the backend code of this one is? This is the backend code. This model, whatever the model I have saved now, this model I have used it for the deployment. I have created a Flask model. This is called as deployment. In the real life, the person, whoever the client is there, the client is going to use in this way. Because they don't know what is Python, they don't know what is machine learning, nothing. They know only if this values, if I input, what is the output I will get. Just they will give the input as 4, 9, 9. They'll just input the values like this and they'll check the values. Now, for example, let us take like this. In this, whatever the model is there, once again, I'm executing this, this one. Okay. This particular code I'm executing. Now I have designed the model with linear regression. Now I have predicted. Now let us change the one more prediction. Let us see with one more prediction. That is model dot predict. Model dot predict. I'm going to predict on the data. An experience of 0 and test score of 9 and interview score of 10. What is the expected salary? So double bracket you have not used. So it is going to throw an error, that reshape error. It is not in the shape of 1, -1. You have given in a different way. You have to convert that one to 1, -1. What is meant by 1, -1 means from 1 to, what is the 1 means? What is the meaning of 1? 1 row. -1 means those many number of columns. Minus indexing of -1. What is meant by -1? Till the last. Till the last, right? So either in my case, it is equal to 1, 3. 3 columns. Either 1, 3 or 1, -1. Both are same. Index numbers. Right? Now here, I'm going to use with respect to double square brackets. It is giving 55992. My model has predicted in the Python, in the Jupyter notebook, inside the Jupyter notebook. Now the same thing here I'm checking 0, 9, and what is the next one? 10. Same answer. Here, whatever I have used it for saving purpose, this model I have saved as model.pkl. Whatever the model I have used, that model I have used here. The same model I have loaded here. Okay. So this Flask file, this website file, it is called as micro frameworks. This I will explain later. Don't ask now. Will not deviate. First, let us complete the machine learning. Later, we'll see the deployment part. This is called as micro frameworks, where the micro frameworks it is going to create using the Flask. Okay, whenever you want to create the micro frameworks, your Python code should be in the .py only. You can't use the IPNB files for creating the micro frameworks. Either you have to go with the Spider or PyCharm or Notepad. Anything is okay, but it should be in the saved in the py file. That is the reason I have used it here in the Spider. Okay. So deployment team is going to write the entire code only in the PyCharm or with respect to Spider. Data scientist will work on the Jupyter notebook for his analysis. That team will work on the Spider or PyCharm, whatever it is, Visual Code or whatever it is. So that is the reason developers will use a different one. Data scientists always use the Jupyter notebook, whereas developers will use always with respect to PyCharm or Visual Code or whatever it is, something. Right? Go slow. Faster. Right? So just you are using the model. See here, just what I have done, the data modeling I have done. And after that, I have done the predictions and I have done the evaluation. Since it is a good model and satisfies my requirement, assume this is the only model I'm having. Directly this model I have saved and I'm using in the future. What I want to explain here is that what you have to do is you have to identify finally the best model. That best model you have to save as a pickle file or joblib file, any one either pickle file or joblib file. In the last class, I have shown you how to save the joblib file. In the next class, I'll show you how to save as a pickle file. Okay, pickle file we can save in this way. I will explain later. Don't worry. Don't focus on this one. Okay, just focus on first you have to identify the best model. Identify the best model and save the best model. Whatever the best model is there, save that one. For identifying the best model, you have to do the multiple things in your own way. In what way you are going to do, that is your choice. Sir, if I want to replace like this, sir, instead of asking that question, replace and check answer. Why that doubt? Sir, if I replacement, what happens, sir? Why that doubt? Check that one. How much time it will take for replacing that one and checking that one? The same time you are asking me the doubt, and if you get the clarification from me, the same time it will take for you. Just do that one. Right? So just everything you bring into the single cell means, if you do the replacement of single value and if you do shift enter, how much time it will take? No, sir, I can't do that one also, sir. I can't replace everything into the single cell. Copy paste also I can't do. Then restart the kernel, replace the value and restart the kernel from the starting. Restart and run all. Click on the run all. Automatically it will only run. You don't need to run. Restart and run all. First you change the code and restart and run all. Automatically it will only change the and it will give the new value as per that one. Right? So now here, whatever the values are there. So this is called as deployment. The deployment, the client will enter the values and he will predict the value. Similarly, like a TV, radio, newspaper, he will enter the value and he will predict what is the value. He will not open the Jupyter notebook. He don't understand what is linear regression. If you say that, sir, I have applied linear regression, means, what is linear regression? Why you are saying all this to me? If I know that one, why I'll give my project to you? I will only do now. So we should not explain them the subject. We should explain them, sir, this is a requirement of yours. That is, you are asked to identify the relation between TV, radio, and newspaper versus sales. So we have identified with the accuracy of 95% accuracy we have identified, or 96%. Whatever the test accuracy you have got, you have to mention that one. Now, the client is intelligent person. Nah? So the client will have some data with him. The client also will have some data. For example, now how many records I have given for you to in the advertising data set? The original data is of 200 records. Records of 200 and columns are TV, radio, newspaper and sales, right? 200 records I have given, out of which you have used 140 records for training purpose and 60 records for testing purpose. 200 records only I have shared to you. But actually I am having 220 records with me. 20 records already with me is there. Additional 20 records are there. Additional 20 records are there, but I have not shared to you. Why you have not shared, sir? Because once you create the model, now you'll say that, sir, I have done the model, sir, 95% accuracy I have got, sir. You'll say like this. Whether you are saying correct or wrong, how I can check that one? I can't see your Jupyter notebook. I'll see only, I will predict on my data. In my data, if I get 95% accuracy, okay, I am happy. In my data, if I'm not getting this one, I will say that your model is not doing best. So once we create the model, once the modeling is completed, we are going to share to the client that as per your requirements, we have done the model and please look into this model. This satisfies your requirement with accuracy of 90%. We have sent a mail like this. The client is going to check. If everything goes fine, means he is going to revert back. SRK, thanks for your work and we appreciate your work, whatever the work you have done, and we are releasing your amount, final amount. The final payment will be released. If the work is not correct, assume this is not satisfying their requirements. I have sent 90%, I have sent the mail, but they have cross-verified, but they are getting only 80%. SRK, we have evaluated your model, but it is not satisfying our requirements. Please redo. Please redo. They'll send a mail like this. I can't ask, sir, what is the problem, sir? Where the problem is there, sir? How you know that problem is there, sir? We can't ask all these questions. Simply they ask it to redo and we have to do. Once again, we have to do. Now this time we have to try in a different approaches. And once this is again completed, again we are going to send, sir, as per your requirements, once again I have done the same work and now I have rectified the mistakes and everything and I'm resending the model. Again, they'll check. Again, they are getting the same error. Again, it is not satisfying. Okay, sir, we understand that you can't do this work. So we are terminating the project. Simply they'll cancel the project. They can't wait for you for lifetime, right? When you'll submit your answers, they can't wait, right? So they'll give one chance for everyone. If you have done a mistake, miss, they'll give one chance. Two chance. If a nice person like me miss, two chances. But you can't expect more than two chances. They simply say that we are canceling the agreement, the project, or other things are there. Simple. Once they cancel the project, miss, furtherly will not get the projects in the company. From that person will not get, friends of this that person also will can't get the projects. So proper care must be taken before sending the final answer to the client. We have to cross-validate ourselves. We have to create a dummy data and we have to see ourselves if required. So before sending itself, we have to do. Sir, first one student will be there. He'll send one answer. Sir, sorry, sir. I have rectified my mistake, sir. I'm resending once again for you, sir. Please check the latest one, sir. Sorry, sir. I have done a mistake, sir. I will resend once again, sir. These things we can't do in the companies. Before sending only, you have to check yourself. Properly, you have to check before sharing me to the answer. Right? This is more important for the professionals. So generally the same thing, juniors will make a mistakes in the company. That is the reason they'll have the seniors. And the seniors or project managers or team leaders, these people will finalize the things generally. Generally they will finalize because they'll check all these things. Because they can't get the kind of project cancellation or all these things from the client. So they will check, they will cross-verify themselves. Right? So now what you have to do is first data EDA, you have to do in a separate Jupyter notebook. Now you have to do the data cleaning in a separate Jupyter notebook. Once the data cleaning is done, okay. Now, once the data cleaning is done in the second Jupyter notebook, the data cleaning is done. Now your question is, sir, what is the train test split I have to consider? Test size, how much test size I have to consider? Test size is equal to how much I have to consider. Minimum of, I've told you 0.2, okay, maximum of 0.3. It should be in between. So give the values of 0.2, 0.3 and 0.25 and 0.3, something. Take a list, L. Here keep the I, for I in range of, for I in L. Whatever the L is there, it is going to take and keep the I value here. First you take the 0.2 and apply the MLR. See the test accuracy, train accuracy and CV. Change the 2.5, again check. Change the 0.3, again check. Now out of these three, which will be good? One will be good, right? At least one will be good, right? That one you select. Now you got the clarity of how to identify the test size. Okay, done. Now, next, after test size, how to identify test size. Now, whenever you are working on the test size, keep any one random state. Something you fix the random state, anything. Because you are identifying this one miss, remaining all the parameters should be constant. When you are identifying one of them miss, other parameters should be constant. So, random state, you fix any one number. 0, some number you fix. And identify first I value. After identifying I value, now I value is fixed. I value is fixed of 0.2, assume. Now you don't know this random state. Now you try for random state, different I values and for I in range of 0 to 1000. Now you identify which is the best I value. How to identify which is the best I value? First you are going to calculate with respect to test accuracy, train accuracy, and whatever the data you are going to get, you have to store in the empty list. And inside the empty list, you have to create a data frame with respect to train, with respect to test, and difference. The difference between these two. Whichever the difference is less than 5%, within that, which is the top one, sort. Apply the sort function, apply the highest one. For example, I have got with respect to 0, 14, 28, 522. These are the values. These random numbers are having difference of less than 5%. You know how to apply the filter, right? Less than 5% filter, you know, right? So you are going to apply the filter of less than 5%. First, you will get the data. Within this, you know how to apply the sort function, right? Sort values, apply the sort. Out of which one is in the highest position, select that random number. That random state you fix here. So once the random state is fixed, test size is fixed, these both should be applied on the linear regression only. For all the regression algorithms, the base model is linear regression. Now you have got, with respect to cleaning is completed, data cleaning is completed. Next, train test split is completed. Everything is done. Now, whatever the train test split is there, this X train, whatever the best answer you have got, this same X train and Y train, you have to use for all the algorithms. Whichever the best one you have got in the MLR, that train test split only, that data only you have to give for everything. In the linear regression, whichever the data is there, that data is the base data. Base model for all the algorithms, the base model is linear regression. Starting model is linear regression. That data you have to give for all the remaining ML algorithms. Now, if I change this cleaning, in the cleaning, if I replace the values, if I treat the outliers in a different way, what happens? You try everything in the MLR only. You try that one. When you are trying one thing, remaining other parameters should be constant. Remember that. Then only you can identify whether you are doing the good or wrong. If other parameters changes means you can't identify properly. Sir, example, one more example in a different way. Let us try with a different way. Now, let us assume there is a students. Okay, students are there. Students one batch one. Students of batch one, students of batch two. This is a different batch. Different students are there. Here, the different students are there. Trainer one. Okay, trainer two. Here, the trainer is explaining the difficult topic like inferential statistics. Here, the trainer is explaining a very dead easy topic like for loop. Assume he is explaining a for loop. We have listened to the class of for loop. Since this is an easy topic, he is explaining in an easy way. We'll assume this trainer is an extraordinary trainer. He is selecting the difficult topic and he is explaining a obviously he will explain in a different way. Obviously, we'll feel that this trainer is a bad trainer. Right? Obviously, we'll decide like this, right? But this is a wrong comparison. What is the right comparison is the same students of batch one, you have to give the same students. Same topic also should be the same. Inferential statistics also should be the same. Again to the same batch. But trainers should be different. The trainer 1 and trainer 2. For example, trainer 1 is explaining hypothesis testing topic means the trainer 2 also has to explain that hypothesis testing to the same batch of students. Then that batch of students is going to select which trainer is best. Easily they will identify. Who has given the easy examples, who has explained the topic in an easy way, they can identify. Now, you want to compare between what? Between the trainers. Which trainer is best? You want to compare this one means remaining two parameters should be same. If you want to compare which batch of students are same means you have to remaining other two parameters should be the same. Which one you want to compare, that comparison only value should change, but remaining all other different parameters should be the same. Then only the proper comparison is called as. Otherwise, then it is not called as proper comparison. Is that clear? Clear? If not clear, I will explain with a different example. Once again, we are having plenty of examples. Infinite examples are there. Concept, same examples are infinite. In a flow, whatever we remember, we can create the example on the spot. But concept remains same. Because infinite numbers are there, na? So obviously infinite options will be there. Right? That is the specialty of the max. Yeah, one more example. Let us take with one more example. Like, take with respect to like this. For example, we are having with respect to a farmer. Okay, there is a farmer and he is doing the farming. Okay, here the land is different and here the land is different. Different land, different farmer. Two different farmers. Farmer 1, farmer 2. Land 1, land 2. In a different locations. Both of them are using rice only. Both of them are incorporating rice only. Means both of them are farming rice only. Rice and rice. But this farmer has given with respect to output of from 1 acre, he has got from assume that is equal to 2 tons he has got. Assume. I don't know exactly. Okay. If you belongs to farmer background means I don't know. Example, I'm in a flow I got like that. I have my explained. Right. This farmer, one acre, he has given output of 1 ton. Now, can you decide based on this? This farmer is very nice farmer. Based on this example, you can decide that this farmer is a very nice person and highly high person, and he can get in 1 acre also 2 tons. You can decide like this because land is different now. If you want to compare between the farmers, the same land, give first time for the land one to the farmer, first farmer, the same land you give to the another farmer, and check both of them how much they are having with respect to. So when you want to compare between the farmers, you have to keep the other parameters constant. If you want to compare between the land, this land is good or this land is good, the same farmer you have to take, and farmer has to use the same kind of rice in the both the lands, land 1 and land 2. The same farmer has to do the same kind of work. Whatever he has applied on the land 1, same work he has to apply on the land 2. Now he'll identify which land is best. Right? Simple. So whenever you are identifying, whenever you want to identify one based on one parameter, identify based on one parameter, the difference. If you want to identify the difference based on, you want to identify the difference based on one parameter, the all other remaining parameters should be constant. All others should be constant. Then only you can compare. Then only you can compare. Otherwise, you can't compare. Is that clear? So if you remember in the last class, in the multiple linear regression also, I have told you the same, where interpreting the quotients, assuming the remaining parameters, holding all other features are fixed for unit of TV price, increase is equal to 0.044 units. I have multiplied into 10,000 and 10,000 into that, 10,001 into that one. Do you remember in the last class? That is on the Monday's class. By assuming other parameters are constant. If other parameters are constant only, we can compare between the TV versus radio. If other parameters also changes, how we can compare between TV and sales? That is the reason holding other parameters fixed. Others are constant. Is that clear? So whenever you are working on the, whenever you want to identify which is the best one, then remaining parameters should be constant. So in that way, first we are going to do the data cleaning. We'll apply the data cleaning on the same ML algorithm, that is linear regression, and we'll identify which cleaning is best. If I do this one, what is the ratio I'm getting? If I do this one, what is the thing I'm getting? Try with all the different options on the LR. Try with try and test split different options on LR. And once you fix it, finally fix the data cleaning. Which data cleaning has given the best one? Fix that one. Which train test split has given the best one? Fix that one. Right? Once which one has fixed, now this is with respect to Jupyter Notebook 2 completed. Your Jupyter Notebook 2 is completed with this. In this Jupyter Notebook, you have done only the data cleaning. Data cleaning and data transformations you have done. Identified which is the best one. Now the data, whatever the data is there, now you start in the Jupyter Notebook 3 by applying various models. Model 1, model 2, model 3 like this. Data should be the same. Clean data, after cleaning whatever the data you have got, data should be same. Now you have to give to the model 1, model 2, model 3. Model 2 means nothing but different algorithm. Model 3, model 4, model 5. Like this you have to try with all the models. Now after identifying all the models, which is the best model you have to identify within that. Finally, that best model you have to save. That is the work of the machine learning engineer. That is the work of machine learning engineer, not the data scientist work. Data scientist work is, if you are doing the same thing in the deep learning also, if you are able to do for images also, if you are able to do for text data also, for what type of data if you are able to do this, then it is called as data scientist. That is the only difference. If you are able to apply only machine learning algorithms, you don't know deep learning means, then you are called as machine learning only. Machine learning engineers. If you know deep learning algorithms, if you know NLP, if you know with respect to open computer vision, if you know all these things, then you are called as data scientist. Only ML you know means you are called as ML engineer. Right? Is that clear? If you know all these things means it is called as data scientist. Simple. Nothing else. Okay. ML engineer is a part of the data scientist only. DL engineer is also part of the data scientist only. NLP engineer is also part of the data scientist only. Okay. Is that clear, guys? So once we create the model, this is the way deployment is. This is the meaning. In the real time, they are going to give on the new data and they are going to predict on the new data. How this one will be done? Miss, first we have to clean the data automatically in this deployment. They will do the whatever the steps we have given, they'll apply the same steps. The only thing is they'll not fit every time. Model already fixed now. They will not even evaluate also. They will do only one thing is called as data cleaning, data transformation, and they will send that data into the model. That's it. Whatever the data they have collected, they will send that one into the model. Don't observe the Python code. If you observe also, I will not explain. This is separate class. Model deployment, there is a separate class is there. For your batch, I may include Azure also. Deployment in cloud. Okay. I will try based on the level of performance. If your performance is nice, miss, I will also get the interest. As the students are performing very well, miss, I will also get the interest. I will also add something. Okay. I'll be always first person to add something or to explain more things. But you're not able to understand the things, the past things only you're not able to understand. What is the use of new things? I'll get this like logical question like this. So day after tomorrow's mock interview, how the performance will decide. Based on the sample, we'll interfere the population data. We'll do the hypothesis testing day after tomorrow. For 2 students, I'm going to interview, and based on that, I'm going to understand remaining students, estimate the remaining students. Sample of 2, estimating 70. Right? Or similarly, sample of 2 students from online, estimating 90. There are 90 students. We'll estimate. So overall, based on the sample size, based on the sample, we'll estimate the population. Right? If the value is satisfying, null hypothesis says that don't add anything. Don't add anything. Miss, no action. Now, alternate hypothesis says that add something. Action. Take action. Right? No action, take action. That will be decided day after tomorrow. Right? If your performance is up to the mark, miss, I'm also happy, right? Is that clear? So, just whatever the previous classes are there, please again observe that one. Practice that one, apply the step by step, and check with respect to the linear. In the linear regression, simply is a different one. Forget about the simple linear regression. Focus only on the multiple linear regression. In real time, we'll have only on multiple linear regression. So, multiple linear regression and polynomial regression. Understand the concept very clearly and how you are fitting the data and how the machine learns the data. And in the polynomial regression, the number of input values. While predicting also, we have to give the same number of input values. Whatever you have, the model was trained, the model.fit was done, right? That line of code, whenever the fit word was applied, in that fit word, whatever the extra number of features are there, in the predict word also, the number of features should be the same. Then only will predict. In the while making the model, you have created with 20 features, while you are asking with 3 features, it will throw an error. Right? The model was designed with 10 features, miss, you have to give 10 features. The model was designed for 2 features, miss, you have to give 2 features. After transformation, whatever the number of columns you have got, that many columns. In this case, the input data of 3 columns are there. Everything numerical data only is there. In the future, you are going to see the encoding. And one of the student has asked me, sir, the past data, whatever you have taken is clean data. That is, no missing values are there. And no encoding is there, directly you have applied. In the future, we'll change that one. When compared to linear regression, polynomial regression, I have shown you how to increase the number of features and what is meant by overfitting and underfitting. And in the next class, in one of the class, I will show you how to reduce the overfitting. In one of the class, I will show you how to treat the missing values. Different data sets, different approaches. Now, at the end, we are going to combine all these things into one, is called as capstone project. In the capstone project, I'm going to include all the things where the missing values will be there, where the encoding we have to do, everything will be there in that. Everything we can't do in the single project. Directly first project only, we can't do that one. Then everything will be complicated. I told you, right? When we are focusing on one parameter, other parameters should be constant. When I'm explaining the train test split, I should not explain remaining things. So in the simple linear regression, I have went with a simple example because first time I'm showing you the modeling and evaluation and that one. So in that case, I should not take the overfitting or underfitting problem. In the second example, I have to show you the assumptions. Now I'm focusing on the assumptions. If the assumptions are not satisfied, what we have to do? In the second example, like multiple linear regression, I have focused on that. Remaining other parameters, I have kept the constant. In the third example, I have focused on the underfitting and overfitting problem. Now, tomorrow's class, fourth example, now I'm going to focus on the overfitting. Now I'm not going to increase the futures or I'm not going to increase this one. I'll focus on the how to reduce the overfitting. If there is a overfitting, how to rectify that one. If the assumptions has not met, what we have to do, that we have seen. If the overfitting is there, what we have to do, that we are going to see in the tomorrow's class. You have applied the multiple linear regression, assumptions satisfied, everything satisfied, but overfitting problem is there. Now what we have to do? That we'll see in the tomorrow's class. Right? Now everything will apply, including the deployment also will apply. That is called as capstone project. That we'll do in the later. That capstone project is equal to your Kaggle completion. So automatically, if I apply the, if I show the capstone project, similar as it is, we have to do in the Kaggle completion. Kaggle is also same to same. What we have to do in the real-time company, Kaggle and real-time companies both are same. Is that clear, guys? Deployment, what is the use of model and how the model was used? It is clear right now. So using your model, now you are going to predict the answers like this. If this is going to work only in my system, if you copy this URL and if you try in your system, it will not work. This is not web URL. It is not with respect to web. It is a local. It is working on the local server. In order to work on the local server, I have this backend, the spider is running. Here the spider is running. And it is open in the local server, not on the web server. Now, this same thing you have to copy into the web server. That will be done by the software engineers. Sir, the same thing, you have to create a website, sir. In the website also, we have to create like this. For example, let us take in the first example. What are the first example? Do you remember that BMI calculator? First assignment. So here, they have created with respect to the website. The same thing they have created, and in the backend, some program is running. In the backend, the program is running. Here also in the backend, model is running. In this case, program is running. But something was written in the outside. They have not written in the HTML, right? They can't write the program in the HTML, right? They can't write the program in CSS. They have to write the program in Python or in the Java or whatever it is. In the programming language only, they have to write. Using any one of the programming language only, they have to write. And that one they have to deploy here. This was deployed in the website. So since it was deployed in the website, so anyone can use. Whereas this one was deployed only in my system. In the local server only I have deployed. So I can use only in my system. Right? Is that clear? Wherever you have done the deployment, there you can apply. So please practice. And tomorrow we are going to see the overfitting problem, how to reduce the overfitting problem. That is lasso, ridge, and elastic net regressions. 3 algorithms we are going to cover in the tomorrow's class. And in the day after tomorrow's class, so with that, tomorrow the entire regression will be completed.